Okay, so if I have x plus y to the power of 0, what does that equal? Perfect. Anything to the power of 0 is 1. X plus y to the power of 1. Just x plus y. All right. X plus y squared. You can expand that one. And I'll do the cubes and the fourth. All right, what's x plus y squared expanded? Yeah, x squared plus 2xy plus y squared. And you're just going to have to trust me on the cube and the fourth one, unless you really want to do it. But x plus y squared means x plus y times x plus y. You FOIL it out, collect like terms, blah, right? Okay. X plus y cubed means you got to do that 3 times, which is going to take a lot of room. X plus y to the 4 times. As this n value here increases, it gets bigger and bigger and more complex. So right now, we are going to look at just the coefficients. So see if I can squeeze this on. All right. At the bottom, this little bit right here. Don't worry about this stuff. X plus y. I don't know how to say this. Well, that gives you 1, right? To the power of 0 gives you 1. So that's a coefficient. If I look right here, it's just 1. If you look at the next one, x plus y to the power of 1, what are the coefficients of x and y? Just 1, right? So 1, 1. If we do x plus y squared, and you look at the coefficients, 1, 2, and then a 1 in front of the y. Okay? So 1, 2, 1. X plus y cubed. 1, 3, 3, and then a 1 again. And we'll do 4 just because it's there. It's 1, 4, 6, 4, 1. Does everybody understand what I'm doing? Where I'm getting those numbers? Yeah? Okay. Now, if we take this little array here and we kind of switch it and make it a triangle, just sort of push over the left side. Looks like this. This is called Pascal's Triangle. Okay. And if you look at it in and of itself, you're like, whatever, big deal. But if you look at the numbers within it, all the way down the sides, it's always 1s. But if you look at the number in the middle, so this 2, it's the addition of 1 plus 1 gives you 2. If you go to the next row, 1 and 2 is 3. 1 and 2 is 3, and then you got 1s on the outside. The next row, start with a 1 on the outside. 3 and 1 gives you 4. 3 and 3 gives you 6. 3 and 1 gives you 4. 1 and 1. What's the next row going to be? What's on the outside? It's always 1s on the outside. And then you add these two numbers. 4 and 1 is 6 and 4 is? 6 and 4 is? 4 and 1 is? And then it's a 1 on the outside. If you take the coefficient, or sorry, the binomial, x plus y to the power of 5, and expand that, this is what you get. And if you look at the coefficients, 1, 5, 10, 10, 5, and that would be a 1, I guess. 1. The coefficients of the expanded binomial match Pascal's triangle. Okay? So when n, so this here is n equals 0, x plus y to the power of 0, because you 1. If n is equal to 2, or sorry, 1, sorry, go by ones. It's just 1 and 1. If n is equal to 2, that's your trinomial that you, or your quadratics that you studied in grade 11. N is equal to 3, so it's a cubic function. There's the coefficients. N is equal to 4. It's a fourth degree or a quartic function. There's your coefficients. And then a fifth degree function. So why is this good? What does this allow us to do? It allows you to expand higher degree polynomials in basically 1 or 2 lines. You don't have to. If you're going to write out x plus y to the fifth and expand it, I mean, you can try it if you want. Yeah, there you go. You have to do that. So you have to multiply these two, simplify it, and then multiply it by this, simplify it, and then multiply it by this. So it's going to take a page. And there's a, well, if I did it, there's like a 95% probability I'm going to mess up a sign, right? Especially if I just make it a negative or something. And there's negatives all over the place. Okay, so this is called binomial theorem. So you're allowed, you can use the coefficients of Pascal's triangle to expand the polynomial, right? So there's a couple things that we want to look at here. First of all, what happens to the degree on the x's as you move left to right? It goes down by 1, right? So it's 5, 4, 3, 2, 1, and then you would write x to the 0, but nobody writes that. Okay? What happens to the degree of the y's as you move left to right? They go up by 1. This is y to the 0, y to the 1, 2, 3, 4, 5. What are the exponents on the x and y in each term always add to? 5. To whatever n is, right? Whatever this number is, they always add to that number. Okay? So, if I asked you to expand x plus y to the 7, actually, let's do x plus y to the 6 first, sorry. So this is on page, is the next page? 416, please. So first of all, we've got Pascal's triangles here. You need to get the right row number, okay? So the first row up here is n is equal to 0. That's n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. We only have the first 5. So we have to figure out row 6 because n is the exponent on the binomial. So what is row 6 going to be in Pascal's triangle? It's always 1 on the outside. What's the next number in? 6. 5 and 1 is 6. 5 and 10 is 15. 10 and 10 is 20. 10 and 5 is 15. 5 and 1 is 6. And then you end with a 1. That's row 6. So now we can expand x plus y to the power of 6. We use those coefficients. We know that the x's will go down by 1 power, 1 degree, and the y's will go up by 1 degree as we move left to right. So x to the 6 is the first term. The second term, there's your coefficient, 6, x to the power of 5, y to the power of 1, plus 15x4, y2, plus 20x3, y3. Does that make sense? Are we okay? Did I do it right? Yeah? Oh, sorry. It's a 6. You're right. There you go. Is that okay? So you just expanded a 6-degree polynomial or binomial in like one line. If you want to see how much that improves, 1, your accuracy, and 2, speed, try doing that on its own 6 times, like x plus y times x plus y times x. It'll take a full sheet of paper. All right? And you did it in one step. Now, try x plus y to the 7. You already did it, didn't you? Are you ready? Is it that? First thing you have to do is figure out the 7th row of Pascal's triangle. And then once you do that, just throw them in. X's go down by 1, Y's go up by 1. Fill in the coefficients. Good? All right. A couple things. How many terms are there in x plus y to the 6? You expand it. 7. How many terms are in x plus y to the 7? 8. It's always n plus 1. Right? So if you go back to the previous pages, if you look here, you read n is 0, you have 1 term. N is 1, you have 2 terms. N is 2, you have 3 terms. It's always n plus 1. Okay? Now, what if you don't need to write this down. If I said x plus y to the 15th, what would you need to do to solve this, to expand it? What's the first thing you need to do? What did you do up here? You have to figure out the row of Pascal's triangle, right? Now, that if you're doing N15 or N20 or any like a higher number, you're gonna have to go through. It's gonna take some time to do that. Now, this is where does everybody have a scientific calculator with them? Okay, take it out, please. This is where the part that I'm just going to tell you to hit a button on your calculator. Okay. Pascal's triangle can be rewritten using this thing called combinations. All right. This C button. So on your calculator, you should have a button. There should be a couple buttons. One will be NPR and one will be NCR, and it may even have a little exclamation mark, factorial sign. We'll learn what all that means at the end of the course. Okay. For right now, we're going to use NC. That should be R, not C. People have those? People find them? Okay. So you can rewrite Pascal's triangle. This is called a combination, the C. We don't care about the P. That's a permutation, and that's a factorial. But we'll learn all that later if we have time. So 0, you would say choose. 0 choose 0 is 1. 1 choose 0 is 1. 1 choose 1 is 1. That's the first little bit of Pascal's triangle. If you go 6 choose 3, that's going to give you 4 in 1, 2, 3, 4. That's going to give you 20. All right, so you can rewrite Pascal's triangle doing this. This number here, if you think about it, is your n value, right? N is equal to 0, n is equal to 1, n is equal to 2, 3, and then this is n is equal to 6. The first number is your n value. So the reason this is good is because then you don't have to memorize Pascal's triangle or write it down to get the coefficients. You can just go, okay, if I'm going to use a simple one here. X plus y to the power of 2. We'll just do that. I know we could expand that easily, but we'll use this just because it's simple. You don't need to use Pascal's triangle. You can go, okay, my n value is 2. So I'm going to be using 2, choose, and then these things, I like to say, these are your, I'm going to write this. This one, so this is your n. This number here is your, not y value, number of y's. That mathematically doesn't, the prof would probably vomit if I said this. But if you think about it, in the first one, if I'm doing x plus y, so say this is x plus y to the 6. We know the first term is x cubed, x to the 6, y to the 0, right? 6 choose 0. I have 0 y's in the first term. When you go to the second term, you know you have 1 y because the y's go up by 1 and the x's go down by 1. So if I'm going to do this one, I'm going to go, okay, my n value is 2. So it's going to be 2 choose 0 because I know the first term does not have a y. And it's going to be x to the power of 2 plus 2 choose 1. The second term has 1 y, right? Does this make sense to people? And then that's going to be x, y, because the x's go down, the y's go up. And the third term is going to be 2 choose 2. I'll just write it, x to the 0, which is 1, and then y squared. Now, I want us to do this on our calculators, just so we know how to use them. 2 choose 2. I need you to do that on your calculator and tell me what it equals, please. Or 2 choose 0, sorry. 2 choose 0. What do you get? 1, which makes sense, right? It has to be 1. So then you just get 1x squared. I'll actually write the ones. What's 2 choose 1? You know it's going to be 2, but make sure you get 2 on your calculator because then you're using your calculator properly. Did we get it? 2 choose 2. It should be 1. Are we good? Okay. Don't want to do that. Don't want to do that. Don't want to do that. Okay, let's just do a practice one off to the side here. So let's expand. Now we're going to change it up. I'm going to do one with you, and then we're going to do one on our own. So we're going to do everything we've done right now is like x plus y. That's not what most binomials are. So where can you do this on your sheet? All right, we'll just do in assignment question 1. We'll do it right there because I'm not going to ask you to do that. So let's do a binomial. What's a binomial? Give me a binomial. Do we know what I mean when I say binomial? 2 terms. Give me 2 terms. Give me 2 terms that are not x and y. They can have an x in them, but okay. I will make one up then. 3x squared minus 4. We'll just do it to the power of 2, so that it's not too big, okay? All right. There's no y there, but that's fine. The y is just sort of a placeholder for the second term, right? If you want to think about it, this is your x term, that is your y term. Okay, are we ready? Here we go. We're not doing it the old school FOIL way. We're going to do it our new way. So we go, all right. How many y's are in the first term? We're using combinations here. 0 y's in the first term, right? And our n value is 2. So it's 2, choose 0. The x term is 3x squared. So in brackets, you write 3x squared to the power of 2. And you could I'll put the y in just for completeness. The y term is -4 to the power of 0. That's going to be 1. All right. But we'll just so we can see everything. So there's your first term. Plus, how many y's are in the second term? 1, because it goes up by 1. So then it's 2, choose 1, 3x squared. Your x term, that power goes down by 1, so to the power of 1, and your y term goes up by 1. Plus 2, choose 2. Again, the x term goes down by 1, so it's at 0, and the y term goes up by 1, so it's now at a 2. Okay? Now we just have to clean that up. All right? So 2, choose 0. If you're always choosing 0, it's 1. What it means is out of 2 objects, how many ways can you choose 0 of them? There's only one way to do that. If you have 2 objects, how many ways can you choose 2 of them? There's only one way to do that. This is permutations and combinations. We will do it at the end of the course. So those are 1 and 1. So I get 1. Now, 3x squared to the power of 2. What's that? 9x to the power of 4. Anything to the 0 power is 1. I'll just put the 1 in just for completeness. 2, choose 1. Do it on your calculator if you don't know it. 2. 3x squared to the power of 1. 3x squared. Negative 4 to the power of 1. 4. We'll clean that up after. 2 choose 2 is 1. 3x squared to the 0. 1. Negative 4 squared. Now you cleaned it up. The 1's on the outside don't mean anything. So it's just the first term is just 9x to the 4. Second term, you got to watch your signs and stuff. 2 times 3 is 6. 6 times negative 4 is negative 24. So it's negative 24x squared. And the end term is 16. Now, obviously, for a binomial, you could just FOIL it out, and it's just as fast. It's probably going to be 3 lines as well. But as this number increases, this becomes the preferred method. All right? Because if I make that 5 or 6, it's going to be a massive amount of work, especially when you start to add in negatives and different numbers. So that's why you write it like this in the first row, and you clean it up. Every question, no matter how big that number is essentially 3 rows, right? The first row has all the combinations and stuff like that. The second row, you evaluate it. Third term, you kind of just clean up like terms and stuff. Okay? I'm going to give you 1 to do on your own. What degree do you want? 15? You serious?
No. 6. Not.
Let's go with, we'll cut it in half. Can't cut 15 in half. 7.5 terms, or 7. Let's do, okay. I like 8. 8's hard enough that you can't do, well, you can do it on your own, but. All right. Where am I going to do it? Where are you going to do it? Is there a blank spot anywhere? Oh, right under the answer key, 15. Can we do there? Or right above the answer key? All right, what's the binomial that you want? You just picking mean numbers. 12? 12?
No.
2x squared plus 4? How about 2x squared minus 5? I wanted a minus in there.
It's already had the number in your head.
No, I just made it up. And we're doing it to the power of 8? Oh, this is gonna, good luck, people. All right. Oh, just for the video people, sorry. I should put the answer up. There you go, video people. If you're watching this at home, there's the answer. All right, now go to 420. Or 419. Let's go to 419. Sorry. Okay. So, no, go to 420. The better visual representation. Okay, so what are some of the uses of Pascal's triangle? Well, if you are planning like cities and you want to figure out number of routes to get to certain places and things like that, you can use Pascal's triangle to do this. So if you imagine that this is like a city block, pretend if it's like this, like that, all right? You got to get from A to B. How many ways can you possibly do that? All right, only moving in certain directions. What you can do is you take this and you tip it on its side and you overlay Pascal's triangle on it. Okay? And what happens is this number right here tells you the number of ways you can go from A to B. There's 10 possible routes without having to go, oh, look, I can go like this, and then I can go like this, but I could also go like this and then this, but I could go like this and then this, and then like, you're not going to do that. All right. So you overlay Pascal's triangle on it, and it tells you the number of ways to get from A to B. Now, how do you do that in reality? So we will go back to here. You don't have to turn it on its side. You can if you want, but there's a way you don't. So if you go back to page 419, we're starting at A, we're going to B, okay? Pascal's triangle has ones all the way down the outside, right? So you put a 1 right there. And then every time there's an intersection where the lines intersect, you put ones just going straight until you fall off a cliff and then you stop. Okay, so we stop there. We don't keep going. I mean, you can keep writing it if you want, but there's nothing there. Okay, and then you go down the other side, 1 and 1. All right, we're moving from A to B. You can only move to the right and down. You can't go backwards. If you can go backwards, then there's an infinite number of routes you can do essentially, right? Because you can be going like this in a circle. Okay, so we always have to move that way and down. So it's Pascal's triangle. This point right here, just look at the lines that are connecting it. What are those numbers? 1, you add them together because it's Pascal's triangle. 1 and 1 is this line right here. You're connecting 2 and 1 to get 3. This one right here, 3 and 1 give you 4. Then you drop down to the next row. This one connects 2 and 1. Here, let's zoom in. That gives me 3, 6, 10. 10 routes to go from A to B. Okay? Is that okay? All right. So let's do, and that's the same one. They just turned it on its side. You don't have to, though. All right. We're going from the bus station to the concert hall, people. All right. Just treat the first little rectangle by itself. All right. Ones go down the side. Boom, boom, boom. Boom, 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 boom. Okay. So this number here is 2. And then we get 3, 4. Go to the next row. 2 and 1 is 3. 3 and 3 is 6. 4, 10. Next row. 4, 10, 20. 5, 15. 35 ways to get to this little, I don't know, bottleneck intersection, whatever you want to call it. Okay? Then you're starting anew. It's a new Pascal's triangle for the next one. Okay? So there's a 1 there. 1 and 1, 1 and 1. So that's 2, 3, 3, 6. Okay. There's 35 ways to go from here to here. And there's 6 ways to go from there to there. What does and mean in math? Multiplication. Yeah. So and means multiplication. So if we go 35 times 6, I don't know what that is, 210. There's 210 ways to go from the bus station to the concert hall. Okay? All right, we'll do one more. This has nothing to do with calculus, by the way, but we're here, so we might as well just do it. All right, we're going from the train station to the football stadium. All right. Start with ones. 1, 1, 1, 1 until it falls off. So you stop right there. You go down the other side. 1, 1, 1, 1. All right, you want to try this one? Go. Anybody stuck at a certain point? You only add the lines that are connected. So if you're here, you only add whatever that line is. So that number there is 4. There should be a 4 here, right? So if there's 4 ways to get there, how many ways are there to get there? Has to be 4, right? Because you can only go that way. You can only continue. You can't come from up here. Same for this one down here. You're just going to add whatever that is. You want the answer? There's the answer. 119 ways. The only 2 tricky ones are this one, the 4, and then this one is 15 because you're only adding that. There's nothing there to add. All right. Is that okay? All right. Let's just get you to do. You want to do some pathway problems? Where are the pathways? There you go. There's some pathway problems. What is that? 9 and 10? Yeah. Just try 9 and 10. You're never going to be asked to reproduce this in the calculus class, but it's fun. I know. Tomorrow we'll do complex fractions and we'll do some symmetry questions, even and odd. And then the prof is here on Friday and a good time to start.